All right, we're doing 5-6B today. We're still doing related rates. That's what they're called. These are the related rate problems. How are these rates related to each other? Okay, so here we go. Strategy for solving them, they're all on your paper. You're going to, write your variables and draw your pictures and differentiate with respect to t, so we pretty much know how to set them up.
So are those all the next steps?
Yeah. So here we go. Example number 1. It says a full cylindrical tank has radius 20 meters. I'll write that down. Radius 20 meters and height 50 meters. Height 50 meters. And I'm going to draw a tank. And it's a cylindrical tank, so it looks like a cylinder. There we go. Okay. And so the radius right here is 20 meters. And the height is 50 meters. And it says the tank is being drained. Okay, so the tank has some kind of a liquid in it, and it's being drained at a rate of 3,000 cubic meters per hour. How fast? Yes, it is. Okay, when I do these problems, they were hard for me when I was your age. They were still hard when I started teaching this class too. But this is 3,000 cubic meters per hour. I always look at the rates they give me in the units. And by the way, it's draining, so it's negative. Okay? And so this is a change in volume over time. So this would be dV dt. dV dt is negative 3,000. Okay? So step 1, I have to draw the figure, which we did. Step 2 asks me to identify the variables and the rates. So I identified R and H, and there's dV dt. Number 3, identify the rate to find. Okay, so what was the question asking? How fast is the water level dropping? We are trying to find how fast the height is changing. Okay? dH dt, exactly. dH dt is what we're trying to find in this problem. Now, step 4 says I need to write an equation that represents all this stuff. So this is volume of a cylinder. Do you remember volume of a cylinder?
No.
We just did it, like last chapter, right? Or chapter before.
No.
Volume equals pi r squared h. Pi r squared h. Now, here's the thing, though.
What is number 3?
Number 3? That's the rate that we're trying to find. See, the height, it starts at 50 meters and it's going down. Okay? This height right here is changing. The water level's at 50 meters, maybe it's completely full, and it's going down at a rate of negative 3,000 cubic meters per hour. The radius, however, is not changing. Think about a full tank, like a metal tank, and it has water in it. And it's draining. Is the radius changing with it? No, the water's going down, the radius is not changing. So R is actually a constant here. So my suggestion is to plug in R into your equation. So the volume equals pi times 20 squared h. So volume is 400 pi h. Okay? What? Yeah. Now, number 5. We're now going to differentiate, take the derivative with respect to t. So let's find the derivative. We're taking the derivative of this guy right here. There's only one variable in it. It's pretty easy to do, right? So the derivative of v with respect to t is dv dt equals, derivative of h is just 1, dh dt. So it's 400 pi dh dt.
Can we sub in 3,000?
Yep. Okay, so that's taking the derivative, and number 6 is to evaluate. Evaluate means we're going to plug in our information. So dv dt is negative 3,000 equals 400 pi dh dt, and we're trying to find dh dt, how high or what rate the height's changing. So we're going to divide by 400 pi. When you plug this into your calculator, make sure that you put parentheses around 400 pi times pi. Okay? So go to your calculator and you go, anyone do it? Yeah? Beep, boop, beep, boop.
2.39.
Nice. Divided by parentheses 400 pi. Yes. Okay, so the height is changing, and I need units too. At a rate of negative 2 point, should we just round to 1 decimal place? It's fine. 2.4, either way, meters per hour. Perfect. Okay, and we should get a negative. It's draining. The height is decreasing at that rate. Isn't that a good problem? Yes, it is. The height of the water. The cylinder itself, yeah, is not changing. So the height of the water starts at 50. All right, next one. One more. Number 2. Hot air balloon. Oh, has anyone ever been on a hot air balloon?
Nope.
I have.
That was fair height.
Yeah? 1994. You guys weren't even born yet. Okay. Here we go. It's true, huh? Shush, Jack. How dare you? You're right. Okay. Here we go. A hot air balloon is placed 500 feet from an observer and begins to rise. The angle between the observer and the balloon is changing at a rate of 0.14 radians per minute when the observed angle is 45 degrees. That just stinks right there. They give you radians and degrees in the same problem. How fast is the balloon rising? Remember, the angle theta is changing. Do not put in pi over 4 until step 6. Thanks, Dad. Okay, step 1.
They didn't close the parentheses, that's actually just
Oh, true.
they started everything.
Way to go, Dad. All right. So here you are. You're an observer. Okay? And you see that there's a balloon 500 feet away. And it is rising. Okay? So here's the balloon. I'm going to try and draw it. I hope I don't draw anything bad. There we go. That's a balloon. Okay. Now, this angle is changing here. This angle of elevation, we're going to call it theta. And we're going to call this h. Okay? So that's step 1, is to draw the figure, label all your parts. Here we go. Now step 2, we need to identify the variables and the rates. Okay? So they tell me that the balloon is changing at a rate, or the angle is changing at a rate of 0.14 radians per minute. So that would be what? Yes. D theta dt is 0.14 radians per what? Per minute. Okay, I'm going to leave things in radians. You could change it to degrees if you want to, but I'm just going to go with radians. And then theta, at the time when this is happening, is pi over 4 radians.
It says do not put in pi over 4.
Right, we're not going to actually put that in yet until way at the end, step 6. Okay, now for part 3, it asks you to find out what we're looking for. Identify the rate to find. What are we trying to find here? We're trying to find how fast is the balloon rising. We're trying to find dH dt. How fast is it going? Right? Because that would be, is this in feet? That would be feet per minute. That's a rate, right? At a speed, feet per minute. Okay, and we need an equation to solve. Okay, so what's an equation that relates this angle with its opposite side and the adjacent side?
Tangent?
Yes, tangent. Yes. So, tangent of theta is opposite over adjacent. What? You have to know trig to be in here? Sometimes. And so that means that h would equal, let's solve for h. H is 500 times tangent of theta. So that would be the answer to number 4. That's the equation that we have to differentiate. No product rule. You are going to need to do chain rule in a way. I'll show you what I mean. Okay. So now we have to take the derivative of h with respect to t, because that's what we're looking for. So dH dt equals, so let's take the derivative of 500 tan theta with respect to t. So it's 500 Do you remember the derivative? Yeah. Derivative of tangent is secant squared theta d theta dt. See, that's the kind of hidden chain rule. Because you take the derivative of tangent, which is secant, leaving the inside alone, then you take the derivative of theta, which is d theta dt. Now, part 6, we get to plug it all in. This is such a good problem. So good. dH dt equals 500. Now, secant squared, that kind of bothers people sometimes, but all this is secant of pi over 4 squared. It's not pi over 4 being squared, okay, remember? It's that you do secant of pi over 4 and then you square that. And then times d theta dt, which is 0.14. Everything's in radians, we're good to go. All right, do you know how to find secant of pi over 4? No? You can plug that in your calculator. Do you remember how to do that? It's 1 over cosine of pi over 4 squared. Okay? I'll show you when I do this on my calculator right now. Ooh, I want that right. Yeah, so you have to be in radian mode. 2, it is 2. It's beautiful, isn't it? So I'm going to go to mode. I'm in radian mode right now. Great. And I'm going to do parentheses 1 divided by cosine pi over 4. And then I'm going to square it. 2. Do you remember what the cosine of pi over 4 was? Rad 2 over 2. That was the one you remember, no? Because sine and cosine are the same there. Rad 2 over 2. And when you flip it, you get 2 over rad 2, and then when you square everything, it ends up being 2. So 500 times 2 times 0.14. Yeah? Times 0.14. Well, I got 140.
I got 140.
Yeah? So dH dt equals 140 what? Feet per minute. So that's how fast it's rising. Is that pretty fast? 140 feet per minute?
Yeah.
Pretty fast.
That's not that fast, is it? Let's change that to miles per hour. Do you want to? No. Yeah. Okay. Because it's fun. 140 feet per minute. How many feet are in a mile? 5,280 feet in 1 mile times 60 minutes per hour. So we'll get miles per hour. So 140 times 60 divided by 5,000. 1.6 miles per hour. That's slow. That's a hot air balloon.
Hot air balloons are slow and they're heavy.
Do you think this is real?
And would you want to go fast? It's gonna be scary.
Yeah, right? Okay.
20 miles